Let's now move on to the data preparation stage. So to start with, we need to do the imports. So as you can see, we are importing Pandas, Plotly Express, and NumPy. Secondly, using the upload button here, we need to import two CSVs we generated using Excel, and just for cleanliness, let's rename them to 2025 and country CSV respectively. Okay, having done that, we can start the data preparation stage. So first of all, what we need to do is we need to import the CSV and convert it into Pandas data frame. So as you can see here, this is the same as the worksheet from the Google Sheets we already know and prepared in the previous stage. Alright, the second step, we want to extract the name of the columns that represent season coefficients. So to do that, I am creating a list comprehension statement that iterates through DataFrame columns and wraps all of the columns that don't have country in the name. So if I call seasons, I have nice set of season column names gathered in a Python list. Next, I want to calculate total points across all of the seasons so that I can bucketize my countries and have some buckets that represent countries that have been in similar places across the time. So I am using the sum, using axis equal to 1 to wrap up the coefficients from all of the seasons, and if I display that, I have a nice summary, and the number 19.75 tells me that this is the sum of all coefficients from Albania from all of the seasons. Alright, the next step is to sort the values. So we have already sum of all points over the time. So right now, using the sort values command, I am sorting my data frame, and as you can see, San Marino is the country with lowest sum of points from all of the seasons. So having done that, I can proceed with another command, and when I have my total points, I can also calculate rank to see like which team had the highest and the lowest rank from all time. So to do that, I have this command called .rank with ascending being false, and then running input data. I can go back to my data frame and see new column called total rank. Good. And what is next? So next thing to do would be to create buckets. So as I mentioned, and what the comment tells, we want to have a bucket that represents 5 teams that were in similar rank over the time. So for example, I want teams from places 1 to 5 being in the same bucket. To do that, we can divide the total rank times 5, but also, given the rank starts with 1, I want to shift it to 0, so that teams from ranks 0 till 4 are in the bucket 0. So this is the idea behind this function, and if I run it and also print the input data, you can see that, for example, here is bucket 5, but also first 5 teams are in the bucket 0. The next step for us is to melt the data frame. So what we want to do is we want to shift the table and basically convert each of the column here into a separate row. So it will be very useful, maybe not in interpreting the data as we do it right now, but it will be very useful to create nice and powerful visualizations. So the syntax is .melt. We need to define ID vars, so what will remain pretty much untouched. So it will be country and total rank, plot bucket, and the value vars will be seasons, which we calculated before. So if we then afterwards display the data melted, you can see that these values are untouched, and the variable and value, which we'll fix in a second, are moving over the time. And these are just two columns that have different values for each row. So let's do the fix of the column names. So to do that, we need to call the DataFrame.columns so that we update the attribute of the data frame and we update the list of the fields to be country, total rank plot bucket, season, and points. So afterwards, if I print data melted, it looks way better. And the final step in this part of the preparation is to sort the values once again. So what I want to do is I want to sort once again by country and by season to make sure everything is in proper order. So running this command, I can then print the data melted sorted, and look, it's now sorted by country and the season. Good. So let's proceed to the next command. So what we will do afterwards is we will create country rankings. And what we want to do pretty much is we want to roll the data so that we want to use windows of size 5 seasons. And pretty much for every country aggregate points just for those 5 seasons. So you can also see sum because we want to sum the coefficients for 5 seasons, and also do reset index to have a proper data structure afterwards. So if I do data melted sorted afterwards, you can see that I have UEFA country ranking from 5 seasons aggregated. You can see, for example, that this value is a sum of 2 previous ones, this value for 3 previous ones, and so on. So we will disregard the seasons because they don't have enough data, but we can clearly see that the calculation is correct. Alright, and this is what we will do in the next step. So we will filter data, and to do that we just call data melted sorted and make sure the season is in this first 4 values and also the current season. So this is not true, which is represented by this character. So afterwards, if we run this command, we can see that data for Albania already starts with the proper season and the rank is 6.625. Good. So the next command is to map properly season order. So these values are not easily understandable for programming languages because this is a string. So it contains both numbers and letters or signs. So Excel will not, or Python will not know well how to sort these values. So what I am doing in this command is I am enumerating through unique values of the season, and given they are sorted, I am also adding index. So I will call 15/16, it will be 0, 16/17, it will be 1, and so on. So that if I print afterwards the season mapping, I have a proper order assignment I can use downstream in my plots. Good. So right now what we can do is we can use the dictionary I just created to create season order column in our data frame. So to define this column, what we need to do is we use a map function that will map season to the value. So if we print the data afterwards, we can see season order is implemented properly. Good. We have 3 more comments to go. So what we want to do next is we want to filter this data a bit and just calculate the rankings as of given season. Okay, so we know what were the country rankings for given seasons, and right now we want to come back to the previous state of the data with every single season having every separate column. So the opposite of the melt statement is pivot, in which we want to index via country, have columns for season, and values being the UEFA country ranking. And we need to reset index for proper data structure. So when I call data with rankings, what happens afterwards is we have back again the data with seasons and country, but the difference is that this value is a sum of previous 5 seasons. It's not just value for 1 season, but sum for 5 seasons. Okay, proceeding to the next command. So what is happening is, once again, we want to retrieve the season names, like a limited set of them, because we already did some cleanups here. You can see it starts from 15/16 till 24 and 25 season. So the last command we would like to run is we would like to iterate through all of the seasons and basically replace the values so that we don't have any UEFA country ranking anymore, but we use rank to build ranks for all of the seasons accordingly. So that if I call data with rankings afterwards, you can see, for example, for Italy, that it nicely progresses over time. So in the first season we have data for, it was on the 4th place, but recently it moved to the 2nd position. Right now we can start previewing the data. So we already prepared some data frames, and the idea is to walk through them and get some intuition what this data represents. So the first data frame is current year, which we actually didn't create yet, but we can do that quickly because it's very minimal processing. So we just read the CSV, sort values by the current season, and update the team's percentage to be like a regular float instead of value with percentage that is treated as a string. So if I run this cell, what you can see is I have different countries and data about how many teams are active, how many teams are there in total, the percentage of the teams that are active, and the current season, so that, for example, if I go down, what I can see is that highest contribution to the country ranking this season has Cyprus, and it has 75% of the teams active, so 3 out of 4. Next, we can go to the data frame called input data. You have some definition here, but it's basically the worksheet we created in Excel and we dumped to a data frame with some additional columns. So sum of the points from all time. Secondly, total rank, so ranking based on the total points, and the total rank plot bucket, which aims to group different countries into buckets of 5 teams, so that the countries more or less had similar positions in the past. Okay, next data frame is data melted, sorted, filtered. So if I open it, it's indeed melted and it's indeed sorted by country and the season. So what it shows us the points column also, which is the contribution to the country ranking as of this season, as well as UEFA country ranking, which is the country ranking being sum of last 5 seasons as of season 15/16. And also season order, which is a helper column that will help Plotly properly sort the season. Data with rankings. Let's run it. Actually, it's some processing. And also data with rankings melted. So if you go to this code cell, you can see that also there is additional function that does the bucketing. So to understand how this bucketing is created, we can come back to Casiesa website one more time, but this time you need to open access list web page. So when you go there, you can see, for example, if we check right now the 10th team, which is Czechia, you can see that already the champion of this country plays in the Champions League stage. The second team, or N2, plays in the second round of qualifications for the Champions League in the non-champions part of the ladder, as well as in terms of Czech teams, we have cup winner playing in the playoffs of the Europe League, and it basically means even this game is lost, it goes directly to the Conference League stage. And the third team is playing in the Q2 of the Europa League, and team number 4 from the league is playing in the second round of the Conference League. So what this function achieves is that it maps based on current situation what will be the number of teams in particular cup. So if I run it like this, I can see, for example, let's take some random value. So Turkey, for example, as of season 24-25 was ranked 10, and it means 2 teams in the Champions League, 2 teams in the Europa League, and 1 team in the Conference League, with additional very important information that 1 team goes directly to the Champions League group stage.